Okay, there's our warm-up for the day. Let me get myself situated here. Okay, O is the center of a circle defined by x squared plus y squared equals 69, or 169. Let P be the point of the first quadrant where x is 5. All right, so we have the circle. Can anybody tell me from conic sections what the radius of that circle is? Remember last year's conic sections work? What's the radius of that circle? Not even close. Okay, you're close. Not half. It's the square root, because this is r squared. So the square root of 169, bam, 13. So just FYI based on your prior learning. Welcome back in here. You should have twice. Okay. First question. What are the coordinates of point P? We know that the x value is 5 because that's what the problem tells us, right? How do you calculate the value of y?
Plug it in.
Which one plug in? 5. 5 in, do the math, go.
Into the circle equation?
Yep. It's on the circle, so plug 5 in for x and go.
Is it the 13 or 169?
It's 169. Yep, the equation.
Is it 13 or 15? 13?
15 squared is 225.
Is it 12?
Wow. Somebody's on the roll today. And okay. Okay, do number 2. I trust that one's pretty easy for you. It's a line of segment. Okay, so that's OP. Check. Okay, now the slope of OP. You can do that one pretty easily, right? 2 points, slope equation. Engineer, do you need help? Do you know how to calculate slope? What happened to you? Has your mind been melted? Man. What's the other? Does anybody not know how to do slope? Point O, what are the coordinates? 0, 0. Use the slope formula. Have you heard that? No. Well, that sucks for you. Yeah, y's over x's. The difference in y's. Yeah, there we go.
Okay.
Alright. Survey says we use this point 0, 0. Alright. Here's where we start to implement perpendicular lines. What is the slope of the tangent line to point P. Tangent line to the circle at point P. The unique thing we know is that it is perpendicular. Negative what? No. You forgot to do something. I'll give you the negative. Negative 5 over 12. So that's the slope of the blue line. Because they're perpendicular. So the green line's 12 over 5, right? Yeah? Jesus? 12 over 5? Perpendicular, you have to flip it and negate it. Oh. So it's perpendicular. Okay, now write the equation of that tangent line. Because you have a slope and you have a point. 5, 12, and the slope. I'm Master. Favorite for the answer on this one. Alright, so have a plate that goes. Anybody else? I have no idea. Vote right. Thanks, right?
I think I got the answer. Is this correct?
I think 14.08 169 plus 12, right? No. Where the 5 and the 12 come from? That's an X.
The Y?
Times X plus 5.
Yeah.
Yes, multiply, and then you'll add that over.
Y is in here.
Right equation like tangent. Right, this one. Look at this line. The tangent line. That's the slope. If you can continue, you're finished, you can continue if you want. Draw the tangent. Number 6, what are we determining? Yeah, which is the x. It's not calling that anyway. Thank you. X-intercept. What's the x-intercept coordinates? And then what is another point of a tangent line? Parallel.
Would it be okay if I convert fraction to decimal?
It's okay. I want you. Are you ready? Now. How many denominators? No, that's the line.
Well, a friend, I designed it, a friend made it graphically. The school I was at, we designed it with a printer. Thank you. Is she correct? And survey says, wasn't agree. Yeah, no, that just tells me nothing. You know?
Yes, no. Oh, yeah, she is. You're supposed to add.
This is correct. So, the y value, the x value, and then the slope. Solve. I think that's right. Remember your decimals? 3 spots. Okay. All right. You have an equation. Number 6 is the x-intercept. We did that 3 days ago? No, it wasn't 3. Maybe it was like Friday. Okay, so we've already drawn that. Check. What are the coordinates of t? Anybody lost? It's the x-intercept. How do we find the x-intercept algebraically? In for what?
Y.
Yep, put 0 in for y. Solve. And then a bonus point on number 8. Anybody that can give me another point on the circle that has a tangent line that's parallel to PT. Put 0 in for y. Got to think here. X-intercepts. So let us equation. The red one. Put 0 into y. 0 into y. Then solve for x. That gives you the x-intercept. We're across the x-axis. Negative 14, knowing 3 divided by negative 5 is 12. Exactly. It's second. Now leave it. So let me show you what negative divided by second. And right? That's react. Yeah, that's right. That is the line. It's not the line value of x. What's the y value of x? Well, 0, right?
I did put 0 in.
Good?
I'm wrong.
Does that nominate anybody to get pissed off? Okay. We put your work on the board.
Yeah, I know. Because 0.
0. For y. We're trying to find out whether that tangent line fits the tangent line doesn't come through because that would be 1 and 2 intersections. That would be a secant line. What we call it. It actually comes out here.
Is that correct?
Looks right to me.
So the x-net?
That is the x.
What?
That's the x.
So it doesn't turn the line out?
That's negative. That's negative. Yeah, you're good. That's the circle equation. So that's telling me that
Why not?
those x are a circle. Right? We need to get to this line. Both. We need the x, y, yeah, we need the coordinates. So what was your fraction? 20. What was the decimal? 33.799? 3 decimal places. So what is the coordinates of the point? Alright, so the question actually asks, what are the coordinates of that point? So you actually have to put it as coordinates. It's the x-intercept, so the y is 0. Alright, bonus point. I have a Snickers bar in my drawer, or a Milky Way. Whoever can answer number 8 gets one of the 2. It's just a coordinate. We need a point on the circle that has a tangent line that is parallel to line PT. This is line PT. So we need a line that's parallel to it and tangent to the circle. Where is that going to happen? You have 1 minute. It's actually easier than you think. What point does that occur at? What point on the circle? Say what?
0.
Taylor, say that louder. Hey, we have a winner! Snickers or Milky Way? Snickers or Milky Way? Here you go. Okay. This was easier than it looked. -5, -12. Those are parallel. You guys remember in geometry,
like alternate interior angles, if those are congruent, we have two parallel lines. Since this is 90 and this is 90, those two lines are parallel. All right? Good. Taylor, that was nice. All right, any questions so far? You following? Now, this is an exercise in writing equations in parallel and perpendicular lines. We're just doing it in a different context. All right, I'm going to help you with number 9. We have a line that intersects the circle in two spots. Can anybody tell me how to solve for those two spots? This is a system of equations. Just curious. If I gave you two lines that crossed, let's say one is y equals x, and the other one is y equals half x plus 1 minus 1, how would you solve for that intersection point algebraically? Anybody? Do we remember substitution and elimination? So if I substitute that in for y, I can solve for my x value, right? All right, so I'm going to do the same thing with these two equations. I'm going to put x plus 1 in for y. There are 2 points of intersection. Solve for the x values. And move on to 10, and 11, and 12, and 13, and 14. Yeah. How many of us are there? This is not an easy one. I mean, we're doing quadratics. So you have to FOIL those. And then you have to solve the quadratic. Probably going to be a quadratic. Nope, it's going to be. Yep, it's going to be a quadratic. Probably going to have to use the quadratic formula, to tell you the truth. You need to take this over here and use the quadratic formula. Get some glasses. Check your work. What y? It's gone. It's x plus 1 now.
How does the 25 plus 4 on the other side of
You subtract it from both sides. We need, so remember, solving quadratics, we need this side to be 0. So we can do A, B, and C, and you can do that. That's the quadratic formula. It always works. Or you can factor that. Take a 2 out. This makes it a lot easier. And factor it. Can anybody tell us how to factor that? Not the answer, but how. How do we factor that? You might want to pay attention here. This is the easy way out. Say that again, Logan. Okay, I want you to be very careful. See that 2 in the front? It messes with that rule. We're going to get into that a little deeper this year. You have to take the 2 out. Now you can use that. Multiplies to get negative 12, adds to get 1. 2 numbers. The add up, or multiply to get negative 12, and add up to get 1. What is that? Negative 3 is one of them. Positive 4 is the other one. So what are my intercepts? Positive 3, negative 4. So this is 3 something, negative 4 something. Okay, you should be able to continue. I will post answers periodically. This 3 minus 3 is 0, so it's positive 3.
I know, but how is that the answer?
How are these? Oh, I get it. Okay. Negative 12 when you multiply, positive 1 when you add. Okay. So just a refresher on quadratics there. I know you guys loved those last year. You're going to get a heavy dose of them this year.
How do we find the y values for the...
Oh, you can do that. Think. You have 2 equations. Pick one.
I have to equation.
Those are your x values. What are your equations?
Yeah, if I get into x plus 1.
I think I found them. Subtract y squared.
3 plus 1 is 1 plus 3 of 1.
You got to think here, guys.
You're done.
Because
How do you
what's the x value for point P? It's 3. So what can I do with that x value in an equation to find it? Thank you. And a really easy equation.
Oh.
But already it's 4 or negative C. Hey, what? Negative 13, are we okay there? What's the slope of this one? Y equals x plus 1, so it's 1. Ah. It says OP and they got the answer for OP. Why would they do that? Okay, pay attention on number 12. I did the same thing that many of you did, and did QP. 12 is OP, right? So the rest of the problems are based on line OP. So you need to use O as your point instead of Q as your point. Okay? Thanks, Logan. You are correct then. My apologies. The slope is 4 over 3, yeah. That's right.
Yeah. They are now, because, see that? This is OP. We did QP.
And I just write Q and then we give them credit because it's Q.
No, because it's not a tangent line then. So if you get to 15, I have the answers up here for the rest of them. If you get to 15, you can justify it. I gave you the answer no, but you need to justify it.
Justify it by getting the slope of O and K.
OQ, yeah.
And
And then the perpendicular to that.
Okay.